So this is the hard part of section P2. It involves negative exponents for the rest of the section, and I didn't maybe introduce negative exponents enough, so I'm going to lecture a little bit theory before I jump into doing the problems. One big thing I always generally like to write right up front, when we start working with negative exponents, negative exponents almost never simplify to negative numbers. In fact, in our class, if there's a problem with a negative exponent and your answer is a negative number, I'm about 99.9, I'm probably 100% sure that you're right. And negative exponents usually give fraction answers. There are going to be exceptions even in this section that a problem starts with a negative exponent and the ultimate final answer isn't a fraction, but we'll get some fractions along the way. And let me show you how negative exponents might come up. If I wrote something like 3 to the second power divided by 3 to the fifth power, this is going to be another problem I'm going to solve multiple ways. If I didn't know how to do this, I can say this is 3 times 3, which is 3 to the second, over 3 times 3 times 3 times 3 times 3. And I can reduce the fraction by canceling. I'm left with, in the numerator, the 3's that I canceled turned into 1's. In the denominator, I'm left with 3 times 3 times 3. If I'm reducing a fraction manually and I cancel out the entire numerator, I need to leave a 1 behind in the numerator. And 3 times 3 times 3 in the denominator is 27. So this should equal 1 over 27. If I did this on my calculator, hit the fraction button, turn it on, hit the fraction button, do 3. I could just hit the x squared key to get a square. Divided by 3x with the square bracket, 5. And I know this is 1 over 27. So there's multiple ways to solve this. One would be to do what I did here. Another would be to use your calculator. Yet another would be to say 3 squared is 9. If you knew 3 to the fifth was 243. And then you can divide by 9. Divide 9 divided by 9. And get 1. 243 divided by 9 and get 27. There's lots of ways to get 1 over 27. The ways that I've shown so far don't introduce negative exponents. However, if I used from section P1 rule 2 that says if you're dividing and the bases are the same, I can subtract the exponents and not change the base. I could have solved this problem or simplified this problem using that rule. 3 to the second over 3 to the fifth is the same as 3 to the 2 minus 5 power, which is 3 to the negative 3. So negative exponents can just come up naturally if you're solving problems that have division using the rules for subtracting the exponents. Well, these answers must be the same. It must be the case that 3 to the negative 3 power is the same as 1 over 27. In fact, my calculator, if I enter 3 exponent negative by the fraction and then 3, so 3 to the negative 3 power, it tells me that it's equal to 1 over 27 because negative exponents usually give fraction answers. Negative exponents almost never simplify to negative numbers. So there's going to be a rule that we learn in this section that relates negative exponents to fractions that allows me to simplify negative exponents. It's the negative exponent rule. And the rule looks so simple, but in applications, it's a disaster. The negative exponent rule just says if you have any number or letter, a base to a negative exponent, I can make the negative exponent positive by creating a fraction with a 1 in the numerator, and that term that had the negative exponent put in the denominator with its exponent positive. This is technically the only rule for negative exponents, but in practice, I'm going to probably add to this some shortcuts that are kind of derivatives of this rule that maybe I'll formalize properly. So the first few problems that we need to do are just numbers with negative exponents. I could do them on my calculator. Like if I was doing 36, I can go 2 exponent negative by the fraction in 3, and then hit equals, and 2 to the negative 3 is 1/8. The answer is supposed to be 1/8. I'm going to use the negative exponent rule. A number with a negative exponent, you can make the exponent positive if you create a fraction with a 1 in the numerator and make the exponent positive. That's the negative exponent rule. A base with a negative exponent, you can make the exponent positive by creating a fraction with a 1 in the numerator, take the base, make the exponent, put it in the denominator. Now in my denominator I have 2 cubed, and 2 cubed is 8. So this answer for problem 36 is going to be 1/8. I'll do the same thing for 38. I have a negative exponent. I can turn my negative exponent into a fraction using the negative exponent rule. A base with a negative exponent simplifies to 1 over that base with a positive exponent. And then 2 to the 4th is 16. I have that memorized. You can do it on your calculator if you don't have it memorized. 2 exponent 4 is 16. If I entered this whole problem, 2 exponent negative 4, I get the 1 over 16 answer. For 40, I can't do this on my calculator, but I can use the negative exponent rule. Base with a negative exponent simplifies to a fraction with a 1 in the numerator, and that negative exponent made positive in the denominator. Same thing with 42. Base with a negative exponent simplifies into a fraction with a 1 in the numerator, and the base with the positive exponent in the denominator. I have to be super careful once I have coefficients. The coefficients usually wind up in the numerator, and I'm probably going to overcomplicate this at this point, but it's probably good to overcomplicate it, and then I'll undercomplicate it. So for 44, I have to think of this as 3 times x to the negative 4 power. And if I even want to get more picky, I'm going to think of this as 3 over 1 instead of 3, just because it's going to make my answer easier to follow. Any integer is equal to that integer over 1. 3 over 1 is just a different way to write 3. And as I go to get my answer for problem 44, if I just left the 3 a 3, it might make it hard to follow my answer. So to get to my answer without shortcutting it, I'm separating the coefficient from the base exponent part. The base exponent part gets the fraction. X to the negative 4 is 1 over x to the 4th. But this coefficient of 3, that's a coefficient. The coefficient doesn't wind its way into the denominator. It's only the base to the negative exponent that turns into the fraction. The coefficient is separate. I'm doing exponents first, and the rules of exponents allow me to make that into a fraction. And now I'm going to simplify this. If you have a fraction, you can multiply fractions by multiplying the numerators and multiplying the denominators. When I multiply the numerators of these fractions, I'm multiplying 3 times 1, which is 3. When I'm multiplying the denominators of fraction, 1 times x to the 4th is x to the 4th. So this should be 3 over x to the 4th for my answer. If you do enough of these problems, you start to get your own shorthand. You can get to the answer quicker. I won't do any shortcuts, but I want you to do shortcuts. And probably by the time I get to the end of the chapter, when we revisit these problems, I might introduce shortcuts. So I'm thinking of 46 as 6 times x to the negative 3 power. I'm thinking of 6 in its fraction form, 6 over 1. I'm thinking of x to the negative 3 in its fraction form, 1 over x cubed. Now to simplify, I have fractions being multiplied. I multiply across the numerator and across the denominator. I go 6 times 1 in the numerator and get 6. 1 times x cubed in the denominator and get x cubed. The answer should be 6 over x cubed. If you can get the answer without showing work, that's better than showing the work that I'm showing. So when you did 43 and 45, if you didn't show any work, much better if you get the right answer. Make sure to check your answers with the answers in the back of, on my webpage, should I say. Here's the world where, if I use the rule, I can get the answer, but it's probably worthy of making a new rule for fractions. But this, if you want to fast forward the video, you can ignore this. But this is the proper way to do this problem. If I wanted to do problem 48 properly, the negative exponent rule says if I have a base with a negative exponent, I could make the negative exponent positive by creating a fraction with a 1 in the numerator, and I can bury that base in the denominator and make its exponent positive. Base with a negative exponent is 1 over the base to the positive exponent. When the base is a fraction, this is proper, but this is horrible. So let me get to an answer here in a second. In order to work on the denominator, that denominator has a parenthesis that has an exponent. I'm going to use rule 3 that basically says that if I have a parenthesis without an exponent, without addition or subtraction inside it, and it has an exponent, I can clear the parentheses by multiplying that exponent by any number or letter that has an exponent, attaching that exponent to any number or letter that has an exponent. So I'm going to attach the exponent and get 3 cubed and 4 cubed. That's the denominator written without a parentheses. And I know what 3 cubed is. 3 cubed is 27. I know what 4 cubed is. 4 cubed is 64. This is a ridiculous way to do this problem because there's a shortcut that we're going to learn here in a second. But this is the proper way to do it. Negative exponents, you can make fractions with 1 in the numerator. The stupid 3-leveled fraction is horrible. To deal with 3-leveled fractions, I usually rewrite the problem as a division. So this part, if I'm solving it using this technique, the proper technique, that fraction bar can be turned into a division sign. Now I have a division sign, and it's a division with fractions. If I'm dividing with fractions, I can invert and multiply. So now I have a problem that has multiplication times 1, and 1 times anything is itself. This is the proper way to do the problem, but it's not the way that I would generally do the problem. So we're going to have a new rule, negative exponent rules for fractions, to shortcut this. This is the proper way. This is the answer. If I had done this problem on my calculator, left parentheses, fraction, 3 over 4, get out of the denominator, right parentheses, exponent, negative 3. The answer is 64 over 27. This is the non-shortcut proper way to do it, but I could make a negative exponent rule for fractions. So the general negative exponent rule if the base isn't a fraction, to say x to the negative n is 1 over x to the n is fine, but if the base is a fraction, I could make the negative exponent positive quickly by just flipping the fraction and making the exponent positive. That doesn't look right. So the shortcut that we're going to involve that for the next few problems, if we have a negative exponent and it's outside a fraction, the shortcut is to flip the fraction and make the exponent positive. So all this horrible work that I just did, which is just using this negative exponent rule and then the algebra techniques that I'm good at, can be avoided. So if I was working problem 48, I have a negative exponent that applies to a fraction. The shortcut strategy to solve this is to take the reciprocal of the fraction, make the negative exponent positive. Now I have a positive exponent. A positive exponent that doesn't have any adding or subtracting inside the parentheses has an exponent outside the parentheses. To clear the parentheses, I will multiply the exponent by any number or letter that has an exponent, attach the exponent to any number or letter that doesn't have an exponent. And here I'm just going to attach the exponent of 3 to the 4. I'm going to attach the exponent of 3 to the 3. Then I have 4 cubed. 4 cubed is 4 times 4 times 4, which is 64. 3 cubed is 3 times 3 times 3, which is 27. And if I'm not good at my exponents, 4 cubed is 64. 3 cubed is 27. Same deal, I'm going to do number 50. I have a negative exponent outside of fraction. I'm going to use the shortcut negative exponent rule that applies to fractions. If I have a fraction with a negative exponent, I can make the negative exponent positive if I take the reciprocal of the fraction. And now I have a parentheses that doesn't have any adding or subtracting. To clear the parentheses, I'm just going to attach the exponent of 2 to the 4. I'm going to attach the exponent of 2 to the 3. And then usually I don't leave numbers with exponents. 4 squared is equal to 16. 3 squared is equal to 9. I should box these answers. Hopefully that motivates you to do 47 and 48. For 52, negative exponent outside of parentheses, I'm going to invert the parentheses, make it y to the 4th over x squared, make the exponent positive. Now I have a parentheses that doesn't have any adding or subtracting inside. It has an exponent outside. I'll multiply the exponent outside by any exponent inside and attach it to any exponent letter or number that doesn't have an exponent. Here it's a double multiplication. I'm going to multiply the 4 and 3 and get a 12. I'm going to multiply the 2 and 3 and get a 6. Can't reduce these because the letters aren't the same. For 54, make my negative exponent into a positive exponent by inverting the fraction. Now I'm going to use rule 3. Any number or letter that doesn't have an exponent, I'm going to attach the exponent. Any number or letter that has an exponent, I'm going to multiply. So I'm going to attach the 3 to the y, multiply the 3 by the 3 for the x, and get y cubed over x to the 9th. Section kind of drones on for a little bit. Let me keep going, and then eventually I'm going to make a part 3, I think. But 56, parentheses with a negative exponent. I'm going to invert or find the reciprocal of the parentheses. Make the exponent positive. Since the parentheses doesn't have any adding or subtracting, I'm going to attach the exponent to any number or letter that doesn't have an exponent written, multiply the exponent by any number or letter that has an exponent, and then numbers with exponents, I'll break out my calculator, but I can simplify in my head, so I'll simplify in my head. 4 cubed is 64, 3 cubed is 27, x cubed is just x cubed. For 56, I should get 64 over 27x cubed. 58, invert the fraction to make the exponent positive, so I get 4x squared over 3 to the 3rd power. Attach the exponent to the 4, multiply the exponent of 2 and 3 on the x, attach the exponent of the 3. 4 cubed is 64, so I get a 64x to the 6th in the numerator. 3 cubed is 27. That fraction 64 over 27 doesn't reduce. All right. I usually shortcut and teach shortcutting, but students do so bad with my shortcutting. Let me just do these properly. 60 is a division problem. The bases are the same, so I'm going to subtract the exponents and get x to the 3 minus 7 power. 3 minus 7 is negative 4, so this is going to give me x to the negative 4 power. That's just using the rule that says if you're dividing and the bases are the same, you subtract the exponents. The instructions for all these problems say simplify the expressions that have negative exponents, write your answers with only positive exponents. So I'm going to make this x to the negative 4 have a positive exponent by using the negative exponent rule, create a fraction with a 1 in the numerator, and I'll make the exponent positive and put it in the denominator. 62, same version. This is y to the first over y cubed, so I'm going to go y to the 1 minus 3. This is going to give me y to the negative 2. Make the negative exponent positive, so this is going to be 1 over y squared. I'm going to treat 64 as two separate problems. I'm going to reduce the fraction 24 over 18, and I'm going to reduce the fraction y cubed over y to the 4th. 24 over 18. My calculator reduces, so I'm cruddy at reducing. So fraction 24 over 18 equals 4/3. I can divide them both by 6. 24 divided by 6 is 4. 18 divided by 6 is 3. And now I'm going to subtract the exponent. I'm going to go y to the 3 minus 4. That's going to give me y to the negative 1. So this is really 4/3 y to the negative 1. This is being too proper, but it's probably good because the shortcuts that I like to use, that I use in practice, a lot of students just can't handle. And so let me simplify this, and then maybe I'll backtrack and talk about simplifying. So this problem I have right now, if I wanted to separate the fraction from the negative exponent letter, I could write it like that. And y to the negative 1 power is 1 over y to the first power. So I can think of this as 4/3 times y to the negative 1, or 4/3 times 1 over y. And then I'm going to multiply across. I'm going to go 4 times 1 is 4. 3 times y to the first is 3y to the first. And I don't need to write that exponent of 1. That's the proper way to do each one of these problems, 60, 62, and 64. That's not the way I generally do these. Usually, when I see a fraction that has letters, I usually take the big exponent minus the small exponent and leave the letter where the big exponent is. If I was doing problem 60, I would do it like this. I would say the x is going to wind up in the denominator because 7 is bigger than 3 and it's in the denominator. I'm going to subtract big exponent minus small exponent, leave the letter where the big exponent is. I can't write a fraction without a numerator, so I'll leave a 1 behind in the numerator. This is just an alternate way to do the problem, and it doesn't introduce negative exponents. Negative exponents usually can be shortcutted around, and that's usually what I do. So if I'm dealing with fractions and the bigger exponent's in the denominator, rather than going through the proper technique of subtracting the exponents, creating a negative exponent, and making the negative exponent a positive, I usually like to examine. I look at the problem. If it's a fraction and I'm dividing with letters, if the bigger exponent's in the denominator, I go big exponent minus small exponent. If the bigger exponent's in the denominator, I do the subtraction big minus small in the denominator, leave the letter in the denominator, write a 1 in the numerator. That's an alternate way to get to the answer. This is the proper way to do it. This is the lazy shortcutting way to do it. In problem 64, if I was being lazy, I would still reduce this to 4/3. But for the y, I'd go, if the bigger exponent's in the denominator, I do big exponent minus small exponent, leave the letter in the denominator. And this is going to give me an exponent of 1 on the letter. And I don't need to write that exponent. That's the shortcut way to do these problems. You could do them proper, just do numerator exponent minus denominator exponent. If that creates a negative exponent, use the rule to make the negative exponent positive. Or if you notice, if the bigger exponent's in the denominator, then you can leave the x in the denominator and do big exponent minus small exponent. If the answer doesn't have a coefficient part, you leave a 1 in the numerator. If the answer would have a coefficient part, you don't need to leave a 1 in the numerator. It's kind of up to you how you go about simplifying these. Let me pause the video. I'll do a part 3 quickly here.